Okay, guys, so let's solve the next question. So next question calls all from source to target. Okay, so we are given a graph, direct acyclic graph, okay, of n nodes from 0 to n minus 1. Find all possible paths from 0 to n minus 1 and return them in any order. The graph is given as following. Graph I is a list of all nodes you can visit from node I, and there is a direct edge from I to node ij. Okay, so here we have graph 1, 2, 3, 3, 0. Okay. There are two paths, 0, 1, 3, 0, 2, 3. Okay, and we have 1, 2, 3, 3. Okay, so we are given direct acyclic graph. Okay, so we direct, okay, of n nodes. From 0 to n minus 1. The graph is given as follows. Graph I is a list of all nodes you can visit from node I. Okay, so from 0 I can visit 1 and 2. From 1 I can visit 3. From 2 I can visit 3, and from 3 I cannot visit anything. Alright, so, and yeah. Here we have 3. From 0 I can visit 3 nodes. From 1 I can visit 3 nodes as well. From 2 I can visit this one. From 4 I cannot visit anything. Okay, so I think that here is actually, we can try simple BFS, and with BFS we can create a new list every time, and add this new list to our, yeah. Add this new list to our next node. And we start with 0. And yeah, going one by one. So for example, so we can do here. So the first question, whether can we have like empty graph? And yeah, and we see that we have at least 2. And yeah, maximum is 15. All right, so let's check. So For example, we have on 0, we have 1 and 2, right? So we can create like a queue, if it's BFS, a queue with all possible lists. So here it will be 1, then it will be 2, right? Then we take this one from the queue, and we are adding 1 and 3, and then we 2 and 3. Yes. Then we again take this one from the queue, it will be 0 1, 0 2. Okay. What about here? Like we know that from 0 I can go to 4, from 0 I can go to 3, and from 0 I can go to 1. Then I have all these elements, and now I know that I have this one actually, right? I know that I have this one, and it's my last element. I think that what I can do, I can try to iterate from 0 to n minus 1, and I can have like a map of key. It will be my next element, like next, and value would be list of previous values. So for example, my map would be 0, empty by default. Then I have first iteration with 0, and I can, for each with 0, I can create, like I can update this map with value. For example, 4, it would be 0 and 4. Then 3, it would be 0 and 3. And then 1, it would be 0 and 1. Then I have iteration with 1. And I'm taking from the map my list with 1. And And then I take this list with 1, and I update this list with 1. With all these values, with 0, 1, 3, 0, 1, 4, 0, 1, 2. Mm-hmm. No, I think it would not work like this. 0, 1, 2, 3, 4. 0, 1, 2, 3. Okay, so I know the final element, and I can check if final element, then I can return. So for example, I can iterate from 4, I can take 0, and if it's 4, then I just return this list. Then I go to 3, I iterate from 0, 3, 0, 3, then 0, 1, 0, 3, 0, 1, 3, 3, 4, 0, 1, 2, 3, and 4. Okay, let me check. So if it's 1, zero, 4, it's understandable. Then if I have 0, 3, and okay, yeah, and then I should take by 3 this element, yeah. Okay, I think I understand. So what should I do? I should make DFS call, and on this DFS call I'm calling my element, my graph, this graph, and then I call this graph of this element. Also, I would have yeah, I would have some list. And return this DFS. So how this DFS would work? So actually I would return here this list to call DFS. Here it would be node. Then I have pass. Then I have this graph. And yeah, I have also list, integer list. Okay. So my base case would be the following. So I have my node, right? So what I'm doing here, I'm adding to the list this node. And if my pass length equal to 0, so it means that I'm currently on 4. Then I should return this list. Otherwise, I should do the following. I should iterate over this pass. And I should have this result. Okay. And I should return this result. And for each, I should call DFS. And yeah, and so for example, I call with 0, right? I have 4, 3, 1. So I have P graph graph P, and graph and list, and then res and all here. Here maybe I should create new array list in this list. Okay, let's run. Yeah. Yeah, probably it should be maybe like this. Maybe let's try to do the following. So I have this list result. I'll make this dfs, return result. Here it also will be result. So yeah, so here also add this result. Here a result add this list and return here. Um, yeah, and here I will just call this dfs. Okay, wait. Result. Okay, so here I have 0, 1, 2, 0, 1, 4. So I have additional paths here, like 0, 1, 2. Okay, so maybe let's do it like this. So if path equal all lengths, but here if node equal to path lengths, only then I can add to result. And let's add this test case. Now, yeah, when path length is equal to 0 and node should be equal to path length, it should be not path length. Maybe graph. Yeah, graph length -1. Yeah, and here I have 0, 0, 2. 0, 1, 2. 1, 2. Okay, so find all possible paths from 0 to node n-1 and return them in order. Okay, but here I have from 0 to n-2, so it will be 0, 2, 0, 2, and 1, right? Because 0 is points to 2, 2 points to 1. Okay, so if node is equal to graph n-1. Yeah, but here, I think here I should do like this, maybe. To remove this if. Let's try. And submit. We done. Let's check. Yeah, I think we're done. So thank you very much. And that's it.